Hey there, Gators. This is chapter material for the psychological research chapter. And I have my puppy here. You might see him throughout the lecture as well. Of course, we're going to start with our student learning outcomes, so please review those. But I have to ask you to start with, why do we need research? So psychology is a science. It's based really heavily in research. And I'd ask you just to think about these statements. Who agrees? Birds of a feather flock together. So just kind of think, yes, I agree, no, I disagree. And then the statement, opposites attract. Do you agree or disagree? If you're like me, you agree to both of these sayings just off the bat. So we've both heard, many of us have heard these types of sayings, and so we're just inclined to go with them. But if we look at them, they're actually opposites. So, do we attract to, or are we attracted to people who are like us, or are we attracted to people who are different from us? So, research then is something that's really needed to help us to determine what is fact and what is opinion, or what are, kind of these old tales that we've passed through generations, but maybe don't have an empirical basis. So that's a big reason why research is important. It's a big reason why psychologists rely so heavily on research. Research also helps us understand ourselves and the world, helps us get an idea into why people behave the way they do, why we think the way we do, and some of how our body acts the way it does. And it's empirical. So with empirical or empiricism, with empirical research, our hypotheses and our theories, they have to be testable. So it can't be something like, in my dreams, I see fish. I can't really test that necessarily. It's not observable, it's not perceivable, it's not necessarily measurable. I could try really hard to write down what I see in my dreams or what I feel about my dreams, but you couldn't go in and also observe the content of my dreams, at least not with the technology we have now. So we really wouldn't call that, perceivable, measurable at this point. So it has to be based on that observation. I should be able to observe this phenomenon. You should be able to come behind me and observe it as well. Or, watch it at the same time and observe it through your own senses. So that's really where we get our information for psychology. The goals of psychology, and these goals kind of go in order. First, we want to describe something, explain it, predict it, and then eventually be able to control and change it. And this, of course, is related to behavior and mental processes. So if we see somebody engaging in bullying, we might first want to describe that behavior. So why would somebody bully someone, in person or via text message? So we just describe what's happening. Subject A sent subject B a nasty text message. Then we want to be able to explain it. So maybe they did that because they're continuing a fight they had at school. We want to be able to predict it. So every time subject A and subject B get in a fight, there will be nasty text messages sent. And eventually we want to be able to control and change it. So we don't want these nasty, text messages, this bullying to occur. So we want to be able to predict when it's going to happen and then intervene to stop it from happening. So we kind of go from the easiest to the hardest goals. You all know the scientific method, so I'm not going to spend a ton of time here, but we're going to question how and why things happen. We're going to have hypotheses, run studies. We're going to publish these results, report them out to other scientists, so that way we all kind of keep science moving forward and redefine those theories. An important thing, though, we have to mention is pseudoscience. So we're going to see a ton of this. I see it every time I turn on my TV, and this is fake science. We know it's fake because there's testimonials, like, moisture all worked great for me. It made my hair and my skin feel wonderful, but there's no real evidence, like 9 out of 10 people saw proof. There's not a lot of real evidence to go beyond that. The claims are not falsifiable, so you can't tell me that I don't feel great. It's not falsifiable. We're going to shift the burden of proof to the consumer, and just really no science. If you want to see an example of how we can see this in TV, there's a clip for Moisturol kind of linked into this slide that talks about, this industry of, kind of creating false science or to peddle products. So scientific reasoning, we've got deductive and inductive reasoning listed here. With deducting, we're starting with a hypothesis, testing it against the empirical world. Inductive, we've got these observations, and they lead to more of a broad generalization. We know what hypotheses and theories are, but we've got them kind of explained here. And this is really a cycle. So we'll have a hypothesis, we'll test it, and this will help us to theory build. So we kind of get that evidence and keep then refining our theory, testing our theory, refining and testing and refining and testing, refining and testing forever for the whole bulk of the scientific career. Sounds fun. Our population and sample, a sample is the group you can get. So that's kind of the reality. And a population is the group you want. So I may want to understand all fifth graders in the world. I'm not going to get all fifth graders in the world. I might be able to get like 10. So that might be my sample. So you want your sample, though, to represent your population. So I don't want 10 of the richest and most amazing fifth graders in the world. That's not going to generalize to the entire fifth grade population. I want a really diverse, group that represents fifth graders. Research methods common to psychology. We're going to go through each of these. This is just a listing. So for case studies, you've probably seen case studies. If you've heard of Sybil or watched the movie or read the book about Sybil, she was someone who experienced dissociative identity disorder, or what was then called multiple personality disorder. But this book and movie was this really in-depth analysis of just her because she was such a unique case. So it helps us gain a lot of information and insight, really looking at rare people. The other individual pictured on the slide is Phineas Gage. So the stick that he's holding actually went through his head. So he's pretty rare. That doesn't normally happen. I hope you've never had a railroad spike through the head. I know I haven't. So it's pretty rare. And so people were really interested then in what's happening with his behavior. These can be amazing, but case studies can also be hard because you're just looking at one person. So it's really difficult then to generalize to a big group. Psychologists love to use naturalistic observation. So with this, we want to understand behavior in the real world. So we want to be inconspicuous, not be obtrusive. This can be just natural. So we just watch people do things as they would normally do. Or you can structure a specific task, like set up a phone booth and see what people do in that phone booth. So people can be watched during specific tasks that you devise. So, Jane Goodall did a lot of this natural observation with monkeys, with apes. Some psychology studies that have been done. The tea room trade was one that's very controversial, but this researcher, went into public bathrooms and watched men engage in sex acts with other men. So since it was a public bathroom, he was able to sit and watch that. But then he followed them home, so you can't do that part. So we don't do that anymore. And When Prophecy Fails was a group of researchers who came in and watched a doomsday cult, for lack of a better word there, kind of watched a doomsday cult fall apart when their prediction that the world was going to end didn't come true. So they sat and actually watched this kind of transpire in the natural world. So these can be amazing types of studies, really, really important work, but they're difficult to control, so you never know what people are going to do. People act differently if they know you're being observed. So if you went into a public bathroom where people were engaging in sex acts and you're like, hey, I'm here to watch your sex acts and learn a little bit about you, people are probably going to act differently. And also you can have bias just from having the observer there watching them. They can introduce all forms of bias. Something that I'm sure you've completed are surveys. Psychologists love surveys as well. They're quick, they're easy. You can administer them online, through paper. You probably get them when you go to the line through Taco Bell. They're like, call us and tell us how was your taco. That's a survey. So these are really, really easy, but I'm sure you can think of problems with them. Some big problems is that can be a narrow focus. The question, the way you ask it really matters. And then people can lie. Or they can just give you the wrong answer, not even trying to lie, but they can just get confused. And all you have is the data that they've provided for you. So it can be a difficult, way to collect data, but also quick and easy. Archival research is something interesting that you may get to experience. And so what this is using existing records, so things that are already there, to answer research questions. So if you're interested in understanding courtroom outcomes. You may be able to go into a large room that houses tons of files filled with outcomes from court cases and just be able to access that data and investigate your research topic. So you don't have to actually talk to native people. The data is all there. So it doesn't take much time and money. You can just go in there and start working. But there's problems because you don't really have control over what was collected. So that's not really within your ability to, to go ask new questions or say, you wish they would ask the question a different way. You don't have control over that. Developmental research is research that I'm really familiar with as a developmental psychologist. One type of this is longitudinal research. So this research is amazing. You test the same group of people over and over and over. So you might collect a group of the 5th graders and then study them at 5th grade, 7th grade, 9th, 10th, 12th, college age, et cetera, et cetera. So you're studying those same group over and over and over. That requires a lot of time and money. You got to follow up with them, and then many are going to drop out. So that's hard. Another thing that developmental psychologists will often use is cross-sectional research. So they'll get a group of fifth graders, plus at the exact same time, like that same Saturday or close in time to that, they'll collect a group of seventh graders. And then maybe they'll get high school seniors. So they're totally different groups, but all within, that same short period of time. So, maybe on just from the month of December through January of 2018, 17, 18, you're collecting then, the fifth, the seventh, and 12th graders. So it's all in one short chunk of time. The problem with that is there can be cohort effects. So there can just be differences between kids who are in fifth grade now versus those who are in 12th grade now. So kind of that, baby boomer versus millennial or whatever distinction, there can be those kind of issues there. So now we're going to get into some of the design types. So with correlations, what we're looking at there is a relationship between two or more variables. This is not cause and effect. This is a relationship that exists. So one that people often mention is there's a relationship, there's a real life correlation between ice cream and crime. And so what that might lead us to think is if you eat more ice cream, you commit more crime. And that's not true at all. So there's another variable that's making that relationship exist, and that's the summertime. So it's hot, you're eating a lot of ice cream, it's hot, you're outside, hanging out with people, and you notice an unlocked car with lots of money in it, so you break in. So the fact that it's hot then actually makes both of those things happen. So our correlations then are measured by a statistic known as the correlation coefficient. For this class, you're not going to need to calculate correlation coefficients, but just kind of understand that they range from +1 to -1. And so that's the whole range of correlations. It shows the strength. So the closer to the absolute value of 1 that you get, the stronger that relationship is. And it shows the direction of the relationship. So if it's a +1 or close to that, +1, then that's saying the variables move together. If it's a -1 or kind of close to that negative, has that negative direction, then it's saying one variable moves up, the other moves down. So as one goes up, the other goes down. If it's close to 0, there's no relationship. So this allows us to predict them, which is one of those goals of psychology, but we know that correlation does not equal causation. So a confounding variable in this example I gave you earlier was the sun. The sun, the heat, was what's making people eat ice cream and commit crime. So the sun is a confounding variable. That's actually the causal factor. So we can actually see some correlations listed out here. So you can see a positive correlation, they're moving together. A negative correlation, like hours of sleep and tiredness. As hours of sleep goes up, your tiredness should go down. So with the negative correlation, they move in different directions. And then with things like shoe size and hours of sleep, there's no relation. So you just get a whole bunch of nothing in those scatter plots. There's many, false correlations. Illusory correlations is the word I'm trying to get out there. These are things that we believe are related, but they're really not. So many times it's things like superstition, like I have to wear my lucky socks or I'm going to fail the game. We think there's a relationship there, but there's not. Science doesn't really show that the full moon makes people behave oddly necessarily. So there's not a lot of strong evidence there, so that might be an illusory correlation. I've linked in some kind of funny examples of illusory correlations down in here. The Spurious Correlations website I've linked in is hilarious to me. So it's finding real correlations that exist in the world, but that are related to some kind of confounding variable. So one that I know he has on there is movies that Nicolas Cage stars in and drownings. And so what it looks like then is that the movies that Nick Cage stars in are directly related and positively and strongly related to drownings. So we would think, oh no, we have to stop Nick Cage from making movies. He's hurting the whole world. But in fact, it's just that he makes movies during the summer most of the time. People are more likely to drown in the summer most of the time. So it's that false correlation. So those can be fun ones to review. Experiments. So this is how psychologists show cause and effect. So we love these. There's some important things we'll have to do when we do experiments. We're going to have to get the right participants, make sure our variables are well defined, and kind of go through some concerns. Our basic considerations, if you don't consider reliability and validity, you might as well just not even do your experiment. So reliability, you need to make sure your results are consistent. So if you measure something, you're going to get that same result over and over. And then validity, are you measuring what you're supposed to measure? So if I give you an IQ test, will I get around the same IQ over and over, or is it going to be like wildly different? If it's wildly different, then the research is junk. And again, with validity, we want to make sure we're actually measuring IQ. So I don't want to measure your body weight. I don't want to measure your temperature. That would not be measuring your IQ. So if it's not valid, then it's junk. So we have to have reliable, valid work. We again want that representative sample. We want the sample to represent the population as much as possible. And it's great when it can be random. So if everyone can have a chance of getting in there, not always easy to do, definitely not easy to do, but it's a great thing if we can get close to it. Sure you're familiar with independent and dependent variables, but our independent variable is what we manipulate. So whatever you're actually doing to the participants, whatever you have control over and you're changing is the independent variable. So you're manipulating it. We can't manipulate everything. So I know I hear that as a criticism all the time of science. They're like, why, the idea that smoking, is related to cancer. Why can't they just do an experiment and solve it once and for all? Because I can't make you smoke. I can't be like, you're going to smoke for 50 years and your brother's never going to smoke. So we can't manipulate that. And so we're stuck with just natural experiments, things that you decide to do or things that occur naturally in the world. The dependent variable is what is measured. So we're going to manipulate something, that's the IV, and then we're going to measure the change in a different variable, that's the DV. So if I manipulate different types of breakfast cereal, then I might measure your hunger or your satiation, how full you feel after you eat those types of breakfast cereal. So I'm going to manipulate something and then measure. We want to make sure we really don't have extraneous variables, so we want to control for all the variables that could mess up our experiment. So if I'm trying to give you different types of breakfast cereal and measure how full you are, I'd want to make sure that I don't have variables in there, or I want to make sure that I've asked you if you've eaten recently, or if you have any allergies, or if you hate a certain cereal. Like I want to make sure that I account for all that so that it doesn't mess up my experiment. So we want to be able to show, that's the whole point, is that if we change something, manipulate something, it causes a change. So we do this, an important aspect of this is how we assign groups. So the experimental group, these are the people that get the manipulation, and the control group does not get the manipulation. So they just kind of wait it out, and then we can compare the two groups to each other. We want to assign people to those groups randomly as much as possible to minimize bias. Not always possible, though, with things like gender, so I can't assign you to be a male or a female. Doesn't happen that way. So blind experiments are wonderful, so these are great things. You often see this in medical research. So if you have a single blind experiment, then the participants don't know if they're in the experimental or control. So the researcher would know, and they would go give them either, here's pill A, and then here's a placebo for this other person. So you're getting pill A, you're in the experimental group. This other person beside you is getting a placebo, so they're in the control group. Placebo is just a sugar pill. So in a double-blind experiment, these are even better because then the researcher doesn't know what they're giving you, and the participants don't know what they're getting. So nobody really knows. I mean, somebody has to know, otherwise the whole thing would just be very confusing. So there's some little, I imagine them like a person, sitting up high, knowing all, understanding the whole experiment. But the people who are actually delivering the medication, the people who are receiving the medication or whatever manipulation it is, they don't know what they're doing. And so that way you can't be like, here's your placebo, hope you don't get lots of pimples from all the sugar, and then you change the results because you know what you're giving someone. So having a double-blind experiment can help reduce that bias. Woo. And then placebos, just to kind of mention that, they're a fake pill or treatment, and a placebo effect is when you think it's going to affect you, and it does then. So sometimes the minute you put a Tylenol in your mouth, at least this happens for me, I feel like my headache's getting better, probably because I just did something to help myself, so I feel like I have accomplished something. Like, oh, I'm better now. We're almost done here. We've got to cover ethics, though. Informed consent, this is something that psychologists really require. They require that we follow all these ethics, but informed consent is letting you know what we're going to do if you're a participant in a study. So, this is what we're going to do, this is what we're going to give you, this is how we're going to do it, and you want to be able to say, I will do this, I agree. And then after the experiment's over, we want to debrief, so just let you know what we did, why we did it. We want to minimize harm and deception, so we can use deception. Deception is used, but we don't want to use it when we don't have to, and we don't want to deceive people for no reason. It needs to be a part of the study. So if I tell you, like, here you go, here's your placebo, this isn't going to do anything, then you'll just know it's not going to do anything. So it'll be useless. So, we have to at least pretend like it might, here's your medication, but we know it's not going to do anything. So it's a mild form of deception. We need to be careful when we use vulnerable populations, and then we often run or we should always, not often, always run your research through an institutional review board associated with your institution that will help to make sure that you're doing the correct thing and following all ethical guidelines. Well, that's it, Gators. We made it through the research methods, research theories, all of these important designs that we use. We made it through. I'll talk to you again soon.